So example 5 is one of the shadier versions of this problem. Once again, we have another function inside that's similar to the others. It's 1 over x minus 2. What I want you to realize about this particular function is that that particular function, 1 over x minus 2, has a discontinuity at x equals 2. So that's much more interesting of an issue, because if I look at the limits of integration, everything's fine. Like, it's defined at 1, it's defined at 5. I have no infinities staring at me that I have to kind of recognize. But I have a problem within this interval from 1 to 5. So I have to address this problem. And you can only address it by breaking it up. This is that third bullet. Where if you have a problem in the interior of that closed interval, that you have to break it up and really highlight what that problem is. So I'm going to have to work with this and say, let's just break it up into 2 separate integrals. The integral from 1 to 2 of 1 over x minus 2 dx, and then handle the integral from 2 to 5. Now, you're looking to get an answer for both of these things combined. You definitely have 2 integrals now to work with. That's your job. And you have to highlight the problem areas that are kind of staring at you. That I've got 2 is my serious problem that I have to identify. And you can't move on until you address that. You can't jump the gun and just go to the antiderivative and just figure it out. You have to address the problem. So I just want to be really clear about that. That is how I grade. And so that's really important to me that you recognize the improperness of this integral. So I'm going to say that in this integral, I'm going to make b go to 2. And I want to be really clear with these limits of integration, right? We're going from 1 to 5. 2 is our problem area, right? I'm going to put a hole there, like there's some kind of discontinuity. 2 is removed from the domain, let's say. And if you're going from 1 to 2, I'm going to let b go to 2, but we're approaching from the left-hand side. See how we're approaching from values smaller than 2? We're going from 1 to 2 on the number line. I like to see it that way. That's the reason for the minus there. We're coming from the left-hand side of 2. Now, I'm going to keep my integral pretty much the same. I'm just going to say from 1 to b, 1 over x minus 2 dx. Now, I'm adding to this my other integral, which I'm going to address the 2 now as my lower limit of integration. And generally, the lower limit of integration I consider as an a value. So I'm going to go a is approaching 2. But when I think about it from 2 to 5, you're approaching 2 from the right-hand side. So that's the reason I'm putting a little plus sign in there. Now, I'm going to recreate my integral, and I'm just going to say from a to 5. Nothing to see here. I'm sort of covering up the problem here with a Band-Aid. And the Band-Aid is that limit in front. So now that I have that sort of working out for me, I'm going to kind of just go all in on one of these integrals. Okay, I'll take a look at the first one. I think you can go through your normal steps of solving this out. This is not a basic integral, but it's certainly doable. It's a little u substitution. Okay, so you're really just integrating 1 over u du, which of course we know is natural log absolute value of u. Let me just throw that in play here. That's natural log absolute value of x minus 2. Now remember, I'm evaluating this from 1 to b. And what I don't want to forget about is the fact that there is a limit outside of here. That is mega important. You're focusing on that antiderivative and working out the fundamental theorem. You're sort of pretending like everything is okay, meaning you're actually going to, I'm still going to carry that limit through, but you're actually going to execute that fundamental theorem of calculus. You're going to put the upper limit in for x, and then you're going to put the lower limit in for x. And then I'm going to regroup, okay? I still have the limit as b goes to 2 from the left. And I'm not going to do anything about the absolute value of b minus 2, but I will evaluate this. This is absolute value of negative 1. The absolute value of negative 1 is 1. Okay. So I know the natural log of 1 is 0. So you just kind of do little bits at a time until you start nearing the end here. So I have to figure out what's going on to the natural log of b minus 2 as b goes to 2. Let's think about that for a second. Off to the side. What's happening here is if I let b go to 2, I have the natural log of something tending towards 0. Okay, I don't want to have to draw like this particular graph. Again, this is a class that is a no calculator class. I want to try to figure out a way of dealing with this. What is the natural log of the inside going to 0? What I'm going to do is draw a graph. Maybe I'll do that down here. I think I have space to do it. Here's a graph of the natural log function. This has to be burned into your brain. You have to know how to graph the natural log function. This is it. It goes to infinity really slowly, right? But it does go to infinity, but it has a vertical asymptote at x equals 0. So if you are going to let the inside, I'll just label this is your graph of natural log of x. If you're going to let the inside tend towards 0, then what is going to happen here is your values are tending towards negative infinity. You're sort of falling off a cliff. That's sort of what your outputs are doing. So you're evaluating this, and you end up with negative infinity minus 0. Well, that is negative infinity. Okay, so what you're going to say about this is you already have the nail in the coffin. You are done this problem, even though I didn't even attempt to work on the other half. What do I do with this? I didn't even address anything. Well, to be completely frank, who cares? You just figured out that the first part of your integrals diverges. There's no hope for the other one. Even if this were to converge to a number like 5, it doesn't matter, because if one of your integrals diverges, you don't care about what's going on. I'm going to totally ignore it and not even show anything, because one of my integrals diverges. The whole thing is a mess. So I'm going to go ahead and state what that means. I'm going to say, therefore, the integral that I was given diverges. Okay? I don't even have to dig in and work on that second integral. It's not necessary. And let's kind of be clear here. It's the absolute value that's allowing me to look at this graph, right? Because I can kind of think all these values here are going to be, if I'm approaching 2 from the left-hand side, things like 1.9, it's an absolute value. So that's why I'm looking at the positive graph over here. Okay, but it's worth knowing what some of these graphs look like. It's worth knowing the natural log of x and what that looks like. It's worth knowing what e to the x looks like. You have to, know some of these things so that you can answer more advanced and fancier problems. Okay.